let's start exercise number 1. So this is an exercise on friction. So for our first exercise and the second exercise, we are going to look at two surfaces, wood on wood. So it's both pine. I've got a block of wood, which is made out of pine, and a ramp. Now both of these are unfinished. That means they're not shellacked or painted or anything like that, but they are smoothed down. So what we're going to do is horizontally, I've got the plank on a horizontal mat. Notice if I push it, it stops almost immediately, and that's because of frictional forces on it. If it were a ball, it would have rolled for a little bit. I have a mass hanger right here, and at the end of the table I have a pulley, and I'm going to put the mass hanger on the end. I'm going to put some mass on the hanger until the block moves with a constant speed. So the first thing we want to do is mass the wooden block. So I'm going to turn on my scale. So this is plus or minus 0.1 grams. This can measure up to 2.5 kilograms or 2,500 grams, which is perfect for this exercise because we're going to get pretty high. So what I've done is I've just put my block on top of the scale, 209.7 grams. 209.7 grams. Okay? And the mass hanger, which is supposed to be 50 grams, is 50.1 grams. 50.1 grams for the mass hanger. And okay, I just measured it again. Oh, look at that. So slightly different than it was before. It's interesting. It depends on how I orient it. That is odd. It's probably because of the way it's loaded. It should be loaded uniformly. It's 210. So 210.0, that's 0.2100 kilograms. And the mass hanger is 0.0501 kilograms, plus or minus 0.001 is the precision. So don't forget to put the precisions on your devices. I'm going to put the block right here, and I'm going to move it towards the end. I'm going to put the mass hanger on the end of the string. Of course, I forgot to tie it on ahead of time. Hold on, I'm just tying the mass hanger on. Then what we're going to do is put the mass hanger over the pulley and see if anything happens. And it doesn't look like anything's happening. So the string is taut. There's now 50 grams hanging off the mass hanger, but nothing happens to the block. Now let me just make sure. Yeah, the string is not quite horizontal. You also want to make sure the string is horizontal, so I'm going to move the pulley down ever so slightly. That's so that you have a one-dimensional, you don't want a two-dimensional problem, so you want to make sure the string is horizontal to the plank, like that. So what I'm going to do, watch the plank. I'm going to start to add small bits of mass to the plank. Small masses to the mass hanger. I can see that it's almost there. I'm going to add, let's see, where's the 20 gram? I'm going to put 20 grams on there and see what happens. Okay, so before we start, I should actually talk about kinetic versus static friction. If you want to measure kinetic friction, which is exercise number 1, once you put the mass on, you have to kind of push it to see if it moves. You have to give it a push initially. Static is when you start putting mass on until it just starts to move. So I'm going to give it a little push, and you see how it stops? That means the 50 gram isn't working. What I'm going to do is, because I've already got, well, I can do this one. It's only 4 minutes in. Let's actually go ahead and do this particular one with no mass. So right now the mass of the block is just 210 grams. There's nothing on top of it. So let me actually put 20 grams on there. Then what I'm going to do is give it a push. It's close. Oh, let's try that again. Okay, maybe a little bit too much. It looks like it may be accelerating. What you want it to do is when you give it a push, it should move without accelerating. It sort of does look like it's accelerating. What I'm going to do now is put 10 grams instead of 20 grams on there. So it's a matter of just twinkling around with the mass. And that looks better. See how it's moving without stopping or slowing? Perfect. All right. So let's measure that mass that's hanging on the end of the string. Oh, my scale just turned off. And then what we'll do is go on to the next video. I'm going to put mass on top of the block and increase the normal force. So now I have 10 grams on top of the 50, so it should be around 60. So for just the mass, for your very first line on your data sheet, there's 0 mass on top of the block. 60.2 grams is the total mass required on the end of the string to make it go. So what you have to do is find the weight of that. Change that to kilograms. That's 0.0602 kilograms multiplied by 9.8, and you have your weight in newtons. So every time we do this, take the mass, move the decimal point over by 3. In this case, it's 0.0602. Then multiply it by 9.8 meters per second squared, and you have your weight in newtons. That's the weight required. That's actually equal to the frictional force. That's the weight that was required to move this block at a constant speed. That means it was equal and opposite of the frictional force. So what you've just done is measure the frictional force once you multiply it by 9.8. The normal force is the weight of the block. So take the weight of the block, 0.2100, multiply by 9.8, and you have the normal force. Then you can, and then put it on your tables. What we're going to do is make a plot of the normal force of the block and all the weight I'm going to put on top of it, and the mass required to get it to move. We're going to plot them versus each other, and the coefficient of friction would just be the slope of that.